Okay, so हमारा next topic है the dependency inversion principle. That is the, I think, last principle from Solid. So what it states that your source code dependencies refers only to abstraction, not to concretion. So concrete implementation, for example, if you so again, this all makes sense only for OOPS concept. So OOPS is the foundation. On top of that, this design pattern was developed. So what it says, so if some class has concrete implementation of method, we should not refer it in other part of the code. Instead, we should refer to the interface from which this class has been implemented or inherited, right? So why? Because if you will not follow it, it can cause some of the problem, which I will discuss later, right? So it is not a hard and fast rule, right? It is very flexible. It's like it's better to avoid that using concrete. And why do we not, should you not use it? I will tell you in a little while. Let me walk you through one example. So this is the application that want to use the concrete implementation class, right? So it is, this concrete implementation is implemented the service interface. So application will call service interface only. So this is abstraction, right? You're not directly invoking the concrete implementation. And so to create the concrete implementation object, it is also calling service factory, and the service make service method. What it will do in the service factory implementation, it is going to create the concrete implementation object, right? And then it will pass to the application, so that application use that object. So and this is the line that these both class are the concrete class and these two are the abstraction. So this is the boundary that is separating the concrete implementation of a code base with the abstract implementation of code base. That what the goal is. So your code base should be separated into two parts. One thing is abstraction and one is the concrete implementation. And your main most of the time, if you are referring one part of the code like some other class, so you most of the time you should only refer to the abstraction, not to the concrete implementation. Why? Because there will be consequences. Your code will not like I will tell you the exact reason. uh, and so here, like this, if you see this class, the service factory implementation, which is a concrete class, it is directly referring to a concrete another concrete class, right? So what it is saying that removing every dependency is impossible, right? So it's saying dip violation cannot be entirely removed. And there is one more reason why it is called dip. If you see this arrow from this point, so this application want to use this, right? So the arrow is going in reverse direction. So that is why it is called calling this is a dependency inversion principle. And it is used in high level architecture also. So that is the what dependency inversion. So one diagram towards abstract. So in later you it's called dependency rule. So we will, like in later chapter we'll discuss that too. Yeah. So these are the few negative points which will happen if we don't follow the DIP principle, dependency inversion principle, design principle. It will going to cause the tight coupling in the code, where some high level modules will be dependent on the low level module, right? And changing in low level module can and might impact the high level module too. So it can the tight coupling, and over the time your code will become rigid and hard to maintain and hard to change. And similarly, following the code duplication can happen, right? It might be the case in concrete module you will duplicate the same logic in more than one class. So giving you a perfect example would be difficult, but it can happen, code duplication, right? But let's think it through why this can happen. Suppose you have a module A dependent on module B, right? Module A is using module B, and uh, and you are also using module C, right? So it can happen that same logic, since they are the concrete implementation. Either B has to use the C logic. So suppose they need some common logic in between, right? So either B have to dependent on C, or if B want to independent with C, they have to duplicate the code in its class. So that is the source of the problem and difficulty in testing. So whenever the systems are tightly coupled, so unit test and testing should be mainly done on independent module, right? So when they're tightly coupled, testing them independently is not easy, and sometimes people then skip that, and which later become the cause of the error and bugs in the system. And lack of flexibility, as it is the like reiterating the same point that what like when your system is tightly coupled, it is less flexible. That's all.